these are the candies we're gonna make. So as you see, we have this little badass candy in the middle here that has been made using some quite cool math operations. For example, arctangent and stuff. Here we use some ping pong, and here we use some sine functions. So they are all very procedural sweets. So we're gonna make the middle one here. So let's make a new scene and don't save this, and let's delete the cube. So if you look at this candy, or you remember this candy, it was like a cylinder, right? So let's add this cylinder. But the problem with the cylinder is that, you know, this face up here has a very round single like blob face, and this isn't good because we cannot displace. I mean, we just don't have enough geometry there. And if you start to subdivide, then it's gonna turn into something strange. It has some, you know, it's not good geometry anyways. So let's delete this cylinder here and let's add a new one. And in this menu here, select the cap fill type to be nothing. So now it's nothing, and we have this kind of a pipe. And what we're going to do is to enter edit mode, select this upper loop here and press Command F and grid fillet. So now it's grid filling, and we are gonna use the one down here as well. So now we have a better cylinder. This is too tall for a candy, so let's go to the side view and select all of that, and let's scale it down for about this size, and also let's move this up half a meter. And this is pretty much ready. Just we need to add some loop cuts to make all the faces look rectangular, not rectangular, square shaped. So this is a perfectly prepared cylinder for us. So now let's go to the geometry node workspace, and this is where the fun starts. Or for some people, if you don't like maths, it's not gonna be fun, but actually I promise you I will explain like very thoroughly what's gonna happen here. So let's add a new set of geometry nodes, and actually let's not use them because I'm gonna explain you in the shaders first. And let's go to the top view, and I'm gonna add a new material and remove the principled stuff here, and let's add some, let's not add nothing actually. So again, I'm gonna use my brother's graphics tablet because I don't have my own. The candy from top down looks like that. We have those like a fan blades or something like that coming from the center, right? Now this is a bit too complex to think of like the solution right now, so let's simplify that. Let's say we don't have them curved, but let's say we just make them straight. So let's for example make 6 of them straight. Yeah, this is pretty horrible. I just have to make it smaller. I'm not a good graphics artist, as you can see. Right, that's... Oh, anyways, you can understand that we have like those... these places are like higher, and the places between those lines are gonna be lower, so that this creates this kind of a... like the surface of the candy you saw, right? So in displacement world, you know, when something is higher, it has the value of 1. When something is lower, it has a lower value. Let's say it's 0 or -1. So let's make those -1. So in the middle here we have -1, and also in all of those black areas we have -1, and when the blue line is in place we have 1 there. So this means this place is going to be higher. Once we have all of those numbers, we can see that we need a displacement map that has these kind of values. Now this pattern is repeating all around this circle, and this tells us that we need a repeating pattern. So what kind of math functions can we use to create a repeating pattern? In Blender we have quite a few of them. We have the sine, which is a smooth wave like that. Then we have a ping pong, which is a triangle wave. And then we also have the modulo, which is a sawtooth wave, like that. Little more beautiful, but like that. Now, because the candy was smooth, I think you can agree with me that we don't need any triangle or sawtooth wave, we need the sine wave. And as you know, the sine wave is infinitely repeatable. It just creates a sine wave out from some values. So for example, let's say we have here the value of 0, and here we have the value of 100, and well, we could have like 1000 here. It just is gonna create more of those waves if you have more values or a bigger range of values. So to actually put this in action here, as you see, we need a range of increasing values all over the circle like that. Because if you use a sine function on this kind of values, we are gonna have repeating waves like that around the circle, which are gonna form our candy. So how to do that? Well, there are a couple of possibilities, and in shaders some of them are easier, but in geometry nodes some of them are not very easy. Let's find the easiest one. What we can do is to use the angle. Let's say this is our start of the circle. From here, it's like a clock, and this thing here is gonna rotate around the circle, and it's eventually gonna make a turn of 360 degrees, right? So the whole circle has 360 degrees of rotation possibilities, right? What we can do is to calculate the angle for the circle here, right? So this is the way we can get a constantly increasing value all over the circle. To do that, what we need to do is to use some trigonometry, because this is pretty much our friend in every case where we need angles. So let's say we have, for example, a point here on the circle, and we want to calculate the angle of this circle or this point like that. So as you see, the angle is gonna be here. This is the angle alpha, and here we have 90 degrees, and up here we have some kind of a degrees, I don't know. And if the legs of the triangle are gonna be the h, which is the hypotenuse. Then here we have the y movement, because this is going up. I mean, you see the y-axis is here, and then we have the x leg down here. So trigonometry has quite a few functions to calculate this stuff. There are 3 functions actually, 3 very useful functions in some cases. First of them is sine. So sine alpha will be y divided by h. So the opposite leg divided by the hypotenuse. Then the cosine is gonna be something different. It's gonna be x divided by h, the adjacent leg divided by the hypotenuse. And then the tangent alpha, and it's gonna be y divided by the x. Or is it divided with the x? I don't know what the preposition there is. We don't actually have prepositions in Estonian, so I have quite a hard time with them. Yeah, so what can we use here? As you see, we don't know the length of the h, because, I mean, I just don't know the length of the h. Like, I really don't know. Then the length of the x and y we do know, because in shaders, as you know, we have texture coordinates somewhere here. And if you take the object coordinates, which are really useful stuff, then you can separate them by x, y, and z. And as you see, the x is gonna tell us the movement on this axis, and the y is gonna tell us the movement on this axis. So we know the x and the y, we don't know the h here. So we cannot use any formulas that have h in it. So sine has h in it, so we don't need the sine at all. Cosine also has an h in it, so we don't need this cosine. But tangent has y divided by x, and this is perfectly possible for us, because as you see here, we have the x and we have the y, so that's pretty useful, right? So dividing y by x, we get the tangent value of this angle, but we don't get the angle itself. So to get the angle itself, we need to use the inverse function. So the inverse function for tangent is called arctangent. So if you take arctangent of some kind of a value, we get the alpha, right? So let's do that. Let's take the x and y. First, let's divide y by the x. So let's use a math node. Here, let's use the y divided by the x, division, and what do we have here? We have something like that. And let's use after that the arctangent. So the arctangent is here, but we don't have an increasing value all around the circle, because we have some black quadrants here. Every trigonometric function has some quadrants, and some of them are negative, some of them are positive. And in our case, we want all of them to be positive and constantly increasing around the circle. This arctangent isn't working for us, because arctangent is only like usable for triangles where this angle here isn't bigger than 90 degrees. You can basically understand we have a very, very steep triangle, and this is like the last thing that can be calculated using arctangent. But luckily we are in a very good place, because we have another function. And this is called arctan 2 or arctangent squared, something like that. Anyways, this is gonna give us the whole circle, and this is a pretty elaborate function by itself, and I don't exactly know how it works, but it works. So switch it to arctangent 2, and as you know, the division, or as you see, the division is already inside this function. You see the signed angle arctangent A over B. So let's just take our A, which is the Y, and our B, which is the X, and plug them here. And we have something like that. And you're saying, okay, this has some black quadrants also, or 2 black quadrants actually. Well, yes, but it isn't very important because we can use a greater than, and as you see, this is actually increasing in value. We just can't see the part here to be increasing because it is negative, and everything negative is converted to black in the display color space. So now that we have our values like that, what we can do is to take the sign of these values, and we should have like these sun rays coming from the center. So let's duplicate this, and let's use this sine function. And we have something there, but because the range is so small for the sign to work, I mean, we don't have any rays here, they are very big right now. We just have to multiply the range to make it bigger. So let's multiply it with a number, like for example, let's make 6. And now we have 6 rays here. Very nice, isn't it? We have done those things here, and now the question is how to make them look like a spiral. So to do that, what we need to do is add something to the to these areas here. I can show you how it works, and then I can explain. We need a vector math node here, and then we need to connect it to the object coordinates and use the length of the vectors, which gives us a basically a gradient like that. You see in the middle, the vector or the distance from the center point of the object is very small, and as it progresses outwards, we're gonna have a bigger distance. So this is how the length works. And now what we're gonna do with the length is to add to the values before taking the sign of them. And we have our spiral, right? It is very subtle right now. So what we can do is to multiply the length, and we have the spiral. So basically, why this works is that right now it looks like that, basically, the thing we have multiplied. Let's put it to 1 actually, so we can see this better. And after that, we are basically adding, let me just check if my color conversion is right here. So after, basically, before taking the sign of it, we are gonna add a gradient to that. So as you see, because we add more to those areas like which are closer to the borders, the white thing is shifting, and now when you take a sign of that, it's gonna give us a spiral. So if I type 6 here again and 6 here again, we have like a lollipop or a spiral basically. So now we have everything here, and we have to put it into geometry nodes. So how do we do that? Well, that is actually pretty simple. So the first thing we need is a separate XYZ nodes. So what we need to do is to select or search for separate, and we have attribute separate XYZ. So let's separate our only attribute right now, the position attribute. So the position attribute into X, then into Y, and then into Z. So we have our X, Y, and Z right now. And as you see, with our Y and X, we have to do an arctangent calculation. So for that, nothing better than a good old math node. Let's put it here and select arctangent 2. Now, the first one is going to be Y, the second one is going to be X. And in geometry nodes, we need an attribute to write the result to or into. So let's use, for example, the angle attribute, which is just a new attribute I made. I could have made here like a tomato attribute. This works as well, but let's use an angle attribute. It makes a little bit more sense. And what is the next thing? We have to multiply it with 6 and actually let's make it visible first. So let's use a vector math node, attribute vector math nodes. And to display something, we have to mangle the position of all these points we have here. Currently we have 290 vertices or points here. As you see, in vertex mode, we have 290 of them. And if you want to displace them, we have to change their position. So I'm gonna add to the position. You see add to the position. I'm gonna add the angle, which is our coming from the arctangent, and result back into the position, which is the thing we're gonna wanna change. So what do we have here? Madness going on. And that's because, well, first, of course, we don't have too much geometry here, so let's add the subdivision surface. Simple, and let's actually make it Catmull-Clark. So yes, this is the thing we have here, looking pretty messy, and that's the problem here. So basically, as you know, the angle attribute here is a float attribute, which means it only has one value inside of it. So you see here, angle has only one value in its column. For example, position has 3 values because position is a vector attribute, and angle is a float attribute. Now, if we use a float attribute here, you know, the position is a vector attribute. So if you want to change the position, we have to change it on all the axes. I mean, it has to know like what is it doing on X, what is it doing on the Y, and what it has to do on the Z axis. So right now we only have a float attribute, and the float attribute is gonna slam this one single value into all of those axes, and this means it's gonna displace diagonally like all over the world, because it's gonna displace on all the axes at once. Now to fix that, we have to convert the angle attribute into a vector attribute that only has those angle values for the z-axis, because we want to displace the candy like only on the z-axis. So let's use the vector math node here. Let's take the angle attribute, result in the angle attribute, and multiply it with a 1 on the z channel. So right now we took the float attribute, multiplied with a vector of 0, 0, 1, resulted in a new angle attribute, which is now a vector attribute, as you see here. So this means that it's only displacing on the z-axis, and this is pretty much the case, as you see here. So if you make this a bit smaller, you see we basically have a displacement dependent on the angle. So here we are displacing 0, right? Or actually negative. We have negative displacement here, and it's gonna increase as the angle around the center increases. So this is a good thing on its own, but now we need to calculate the sign of it. We can do the multiplication things and all that afterwards. So let's use an attribute math node and calculate the sign of this angle. And you see we have something here, but it isn't visible because you have to multiply it with something before that. So let's take a math node and put it before that, and let's multiply the angle attribute with a float of, for example, 6, just like in shaders. And look at that, we have the early stages of a candy here. We could actually add some more geometry. It's gonna be expensive, but let's add something. So now we need to tackle the spiral stuff. So to do that, let's check the shaders. We need to add, before taking the sign, a multiplication of the length of the vector. So let's first calculate the length. This is pretty easy to do. We just need a vector attribute vector math, add it here. And let's calculate the length of our position and just write it to an attribute called length. Very boring name for an attribute. Now we have the length attribute, as you already see here as well. And what we need to do with it is to add before taking the sign. So let's use the attribute math node and let's add to the angle another attribute called the length. And what do we have here? We have a spiral, a very faint spiral, but we have a spiral. We also have to multiply this before the addition so that it becomes stronger. So to do that, there is nothing easier than just add a math node and multiply the length attribute with a float value of, for example, 6, right? And this is very well done. I'm gonna apply the scale for just in case when I could have some problems afterwards. But here is our candy, and it seems to be working pretty nicely, but the problem is that we have also displacement down here. Basically, we have to multiply the displacement attribute, which is the angle attribute, because this is used for the displacement, we have to multiply it with a number that has the value of a 0 down here, and that is going progressively up and reaching some kind of a positive value up here, so that we have displacement up here, but we have nothing down here. Sounds simple. How do we do that? Well, we have our z attribute. As you see here, the position has been separated into x, y, z. We use x and y for the angle calculation, but we don't use the z in any ways. The z is sad. Let's use the z because this has the value of 0 down here and a positive value as it goes upwards, right? So let's multiply our angle attribute. Let's multiply our angle attribute with the z attribute. And nothing has changed. Maybe a little bit. Let me check. Yes, something has changed. And the problem here is that, you know, it has this little yellow dot here. This is the center point of the mesh, and the z, the z attribute is being calculated from this point. So we don't have this kind of range there. We actually have 0 in the middle, and then we have increasing values upwards and decreasing values downwards. So right now we only have like some kind of positive displacement up here and some kind of a negative displacement down here, and nothing is working as we intend to. So let's delete all of that. And what we have to do is to move the center point basically, or to shift the z attribute, but I think it's easier to move the center point. So go here and select affect only origins, and now what we can do is to shift S cursor to world origin and shift S selection to cursor. So now the origin is exactly like in this very precise location. We can uncheck the origins here. And now we have displacement only on the z-axis, like only on the top, right? Very simple. Now the problem is, for example, if you want to have a little bit taller candy, then if you move those up, you see it's gonna have more and more displacement over time, and this isn't very good, at least I think so. So to fix that, we have to clamp the z attribute so that it is only between 0 and 1. So we have no displacement up until full displacement, but nothing more. So for that, we have attribute color ramp. So let's put it before we multiply, because if we would clamp this afterwards, this wouldn't have any effect at all. So let's take the z attribute and let's result in also the z attribute. Now this is clamped, so if I move this thing upwards, it's gonna rotate, but it isn't gonna displace anymore. So this is pretty much fixed, and also what I'm gonna do is to select the faces down here and make them bigger a bit, because using the linear, what is it called? Proportional editing, right? So linear proportional editing, and I'm gonna scale it to make it a bit bigger, something like that, let's say. Looks pretty nice, I'd say. So this is basically the candy. I mean, you can add some controls now, so let's go here. Let's add controls for the first thing here, which is gonna change. Let me see what it's gonna change. The number of those, what are these called actually? Number of lines, number of segments, something like that. So let's just call this the number, right? So we have a control for the number, and there is a horrible, not a horrible problem actually, it's just a little problem we have to fix. You know, it has this kind of a seams, right? As you know, the seams only appear when the number isn't a full number. So for example, if you have 5, we don't have any of those seams. If you have 5.2, we have those seams. So we have to have some kind of a math operation between here that basically removes those 0.2s, 0.3s, 0.7s, whatever, after the whole number. So for that we have truncate, the operation called truncate. Here you see truncation, the integer part of a removing fractional digits. So let's put it here. It's gonna convert all those numbers into whole numbers, which is very useful, at least I think so. So we have a control for the count, and we also have the control for this thing here, which is doing what it's adding the rotation, right? The curvature. So the swirliness is in its place and doing something like that. So the candy is ready. Now we only need the shader. So for this shader, Let's go to the shading workspace and let's see what we have here. We have exactly nothing. Let's add a Principled BSDF shader. Principled BSDF. The shader is actually pretty easy. I don't know, like, yeah, it's gonna be easy, but maybe you learn something from here. I do have something that could be interesting. So texture coordinates, I should explain what I'm doing here actually. As you remember, my candy had dark chocolate on the top for the spiral, and also it had white chocolate down here. So to do that, we have to have a mask for the lower places of the candy and the higher places of the candy, for the high ground and the low ground. So let's use a separate XYZ. Separate the object coordinates into X, Y, and Z. And the Z is gonna be the most useful one because it gives us the gradient. So now if we wanna add some contrast, what we can do is to use a power node. So let's use the power node, which is basically giving us contrast. And I'm gonna make an explanatory video on the power soon, maybe in the next, let's say 2 weeks. I'm sure this will come out. Anyways, we can add some more contrast like that. And this is the way we can do that. And now if you want to control this further, we can use a color ramp and do something like that. This seems to be a nice thing. So let's use those as the base color. Let's check how it looks. And the first problem is that we have this kind of an ugly thing in the middle here, and we can fix that by using a modifier I actually have never used before, I believe. So this is the smooth modifier. So you just add a factor that seems to be working nicely. I mean, something like 0.5 is apparently good. And you add some repetitions like that, like 20 repetitions. And this is working pretty nicely. Or 10 repetitions works well. So this is the thing fixed, and now let's go to the material preview. And the dark areas are gonna be white chocolate. So actually I'm gonna add some more. Yeah, dark areas are gonna be white chocolate. So something like that, and something a little bit yellowish, and something brighter. No, it isn't white chocolate, definitely. Anyways, I'm gonna make the dark chocolate first. Something, this looks like not definitely chocolate, and I think this is chocolate, fair enough. So this is basically the candy. As you see, the white chocolate isn't fully white and also has a little bit of a yellowish things here. So this is basically the candy. And also the specularity. The specularity basically is how reflective this mesh is. So chocolate isn't reflective like that. It also isn't like that. So it's for about I'd say 0.3 or something like that. At least I found this the most chocolatey. Let it be like that. And roughness. This is quite molten, but we can use something different here as well. So let's say something around that seems to be working pretty nicely. So the chocolate looks like that. Also some subsurface scattering, because you know, chocolate has some light passing through it. And don't add too much of that, because this is just gonna look very cheap. Like chocolate is gonna be like greasy or something like that. So this is the chocolate subsurface scattering. Now, as you remember, my candy also had this kind of a sprinkles. I'm gonna add them using procedural noise. So let's add a noise texture. Bam, noise texture. And let's add a color ramp. I think some things are just not worth explaining. I mean, you can understand them after I made them. So for example, this is the case with the noise. So if I increase this constantly, you see I have some things appearing on my candy. Now, first, of course, you see they are very squeezed on the z-axis. So this is the problem with mapping. So let's use object coordinates for the noise texture. Now they're better, but there are still not like some dust or some powder on the candy. So let's add more detail, for example 8, and let's add some more roughness, like that. Ooh, that's some kind of a powder already. So let's increase this to around here, and this seems to be like a powder on the candy. Now, how do we add some powder only down here and not up there? Well, for that we have to use our z coordinates, because those give us like the possibility to differentiate between the higher and lower parts of the mesh. So let's use the z coordinates, and actually I'm gonna add a different one, and you can see in a minute why. So I'm gonna add the z coordinates here, and right now we have a dark like area here and the white area here, and this means that we basically have less sprinkles down here and more sprinkles or this powder up there. And this isn't what we want to do, so we need to invert this. And if you want to invert this, well, you can just use a subtract node and subtract the thing from a value, for example 1. So why does this work? Well, it works because you see down here we subtract nothing and up here we subtract a lot. So if we subtract a lot from the number of 1, we get a 0 up here. And if we subtract nothing from the number of 1, we get the number 1 down here. So this is how it works. So this is inverted, and now I'm gonna multiply it with the color ramp. And the order is really important here, because why is it important? Right now, when I have done it the right way, you see basically the sprinkles, we have a lot of like this powder here. And as it goes upwards, we have less and less of powder. But they all have the same brightness. I mean, they're not just fainting away. If we would do this in the different directions or in a different order, so we would do something like that, then we would just have sprinkles the same amount all over the candy, but they're just fading away, and this isn't realistic at all. I mean, what kind of a powder has opacity settings? Like, none of them. So we can just remove this multiply here and put it before again. So this is the setup here. I'm gonna make this a little bit more visible. This is the thing here, and now we have a problem where we have really like a really sharp line where we have a lot of those powders, this powder, and up here we have nothing. I want this to be a little bit more gradual. So what I can do is now to add a mapping node before this separate XYZ and scale it on the z-axis like that. Like, let's put 0.15 here. And now let's do something like that with the color ramp. You can also change this with the subtraction node. The right amount of powder on the candy. Maybe 0.2 works better actually. Yes, so this is the reason why I added separate XYZ. Because if I would have used the mapping for this one, it would have messed up the chocolate colors. So now when I preview this shader, we only see the chocolate because we haven't used this this powder thing here in literally any ways. Let's use a mix RGB and let's add it to our base color by using this as the mask and using another color down here, for example green. And now we have some green things down here. I'm gonna switch them to red because this seems to be tastier, you know. So let's check how this looks, and it looks like that. Maybe we need to add some more of those with the color ramp. Yeah, this is nice. Right. Seems to be working pretty well. You can also add some bump mapping, you know, if you want to be extremely realistic. So let's add those mappings to the bump. And now we have bump like that, and this isn't very good because this is very strong. So let's add a really weak bump here. So for example 0.001, and let's maybe also make it a bit weaker. And let's see how it looks. Looks like that. I think it looks a bit better. Maybe it's still a bit strong. So let's add like 0.1 for the bump, or 0.2. Yes, this seems to be working better. Anyways, this is the candy. And the other candies, including the paper thing under them, are gonna be on Patreon because this video is already very long. If you're interested in making those, you can check it out. And I hope you learned something useful from here. Yes, see you next time.